Hello everyone, this is Orhan. In this video, I will make a brief introduction to building a predictive model, which is basically a regression model, and that model will be very simple with two variables. Once again, this is our Excel sheet, and then the purpose of our analysis is going to be finding a relationship between S&P 500 returns, which are in column F, and Apple returns, which are in column B. In different settings, we might have more than two variables, but in our settings, since we have only S&P 500 and Apple returns, we can represent these data on X and Y coordinates. So basically, we can put Apple on Y-axis and S&P 500 on X-axis. So every single day can be represented by a point of which X-axis is going to be S&P 500 return and Y-axis is going to be Apple return. For example, look at the very first day. So S&P 500 return is 0.63 and Apple is 0.65. So every single day can be represented by a point, and the whole purpose of the analysis is going to find a line which basically best represents all of these points. And the ultimate aim of regression analysis is to find a regression equation between X and Y so that alpha represents the intercept, beta represents the slope. If you can estimate alpha and beta, this can help you predict future returns of Apple based on S&P 500 index. I'm going to perform the regression analysis in two ways. The first way would require two libraries. The first one is Seaborn and the second one is matplotlib. Both of these libraries are going to help me to depict the situation visually. So let me start with SNS. Now let me run the code. This was the idea I was trying to explain you a moment ago. On y-axis, you see Apple returns. On x-axis, you see S&P 500 returns. The whole purpose of this analysis is to find the equation of this line here. Once you find the equation of the line, you can use that equation to predict for the future. Now let's start with the machine learning approach. First, let's import the required libraries. Okay, as you can see, there are two main libraries here. The first one is linear regression, which you can understand from the name is going to be used for linear regression. And then second one is train test split. So basically train test split divides the data into two pieces. The first piece is going to be used to train the data. We are going to use that piece, train piece, to calculate an alpha and beta. And then we are going to use that alpha and that beta for the rest of the test data to see if it is working or not. Basically, we are going to use one portion of the data for training and the other portion for testing. Now let's prepare the predictor and outcome matrices. So the predictor is going to be only S&P 500 index and outcome is going to be Apple itself. So that's why I'm going to write as follows. Even though the predictor is only S&P 500 index, which is SPX, I will mainly be using a long way. So this command is going to take all the columns and exclude which we don't need. So basically excluding Amazon, Date, Microsoft, IBM, Apple only leaves us with SPX. I'm using this long method mainly because in machine learning we would have like tens or hundreds of columns and we would be excluding the columns that we don't need. So that's why the predictor might be more than one. In this case, I only have one. So predictor is going to be defined as follows. and outcome is going to be only Apple. Now I will be defining predictor column. An outcome column. And run this. So up to now it's working. And now we are going to use train and test procedure. Basically I will be copying and pasting this part because it's very long. And then run this. It's running. Now the model is going to be linear regression. So right now I'm just following the procedure to run regression. So basically what I do here is I'm just like dividing the data into two pieces. So test size is going to be 40% of the data, train size is going to be 60% of the data. So taking 60% of the data, I'm running a linear regression. So 60% of the X variable and 60% of the Y variable are going to be used to find an alpha and beta from the train data. And then using the X train, I'm predicting Y's, and this is going to be the predicted values from the train data. So let's run this. It's working. Basically what we are trying to do with train and test split is as follows. So assume that this is our data set once again. What we do is just we divide the data into two pieces. So the first piece is going to be used train data. So 60% of the data is going to be train data, and 40% of the data is going to be test data. Linear regression with 60% of the data, and then let's assume that we get a linear regression line something like this. So this is going to be our train linear regression line. And then we use the same alpha, we use the same beta, and then we extrapolate this line, we kind of extend this line, and then assume that that's going to be the same thing for test data. In reality, test data's linear regression line is something like this. So that's why there's a kind of like error here. So the dashed line is my extrapolation, the red line is the reality. And that's what train test split is doing. Using 60% of the data, we are extending the data. So having said that, let's go back to our analysis. So Y-pred here is basically the dashed line that I just showed you a moment ago. It's my prediction, but in reality, that might not be true. Now I'm going to write a code to find the difference between the Apple data and then predicted Apple data. So this is going to be basically in the train data set. Now let me run the code. If I ask Python to show me the Y train, you will see the Apple data. So this is Apple data's first couple of columns. So you might be saying, what is this 1884? Well, it's basically taking random data from Apple. So these are random numbers from Apple. And if you ask X train, you will see S&P 500. So these are S&P 500's corresponding numbers. Basically, I am here. I'm in this blue part of my regression analysis. So I trained my data. Now I have to test it, whether it is working or not. But before testing, let me show the coefficients. So what are these alpha and beta? To get these, we have to write this code. So if you run this code, you will get the coefficients. So intercept is 0.005, slope is 1.2. So basically in finance, this 1.2 is called beta, which kind of measures the responsiveness of a stock to the market. So basically it shows how much a stock responds to what happens in the market index. So this is Apple's beta, and then every single stock, every single company has a different beta. So now let's take a look at the test data. So how are my variables behaving in the test data? To do this, let me write a code and then run this. So this is going to be my predicted values for the test part of the data, which is red part of the data. Basically, I am continuing this dashed blue line and then to see if it is really predicting apple there. Now we come to the point to evaluate the performance of our model. To evaluate the performance of our model, we need another library, which is going to be as follows. So this R2 score is called R-square in econometrics. R-square is measuring the performance of our model out of 1. So if R-square is 100%, the model is perfectly predicting and maybe overfitting the data. And if it is 0, so it's not predicting anything at all, basically very roughly. So we have to just ask Python to calculate the R-square. And then when you run the code, so training set R-square is 56%, validation set, test set is 52%. These are out of 1, so 1 is 100% is the perfect R-square. So basically these are not great, but these are not bad either. So once you have another model, and then you can be using these values to compare the model. So if you have a different model with, let's say, 60% of R-square, so that model might be better than this model. So another performance measure is called mean square error. Mean square error is basically calculating the difference between the predicted values with this blue dashed line and the real y values here in that region, test region. So remember, this is test region here, this is train region here. So what is the difference between any y value here and it is predicted value on the dashed line? So any y value here, predicted distance on the dashed line. So these are going to be the differences. So we are taking the differences, we are squaring them, and then we are taking an average. So that's why it's called mean squared error. So the code is as follows. And then when you run the code, it's going to give you a mean square error of 0.00014. So basically, there is no benchmark here. Mean squared error is used to compare different models. So if there's another model with a lower mean squared error, that model might be better. So let me summarize what we did in this class. In regression, I showed you two models. The first model is a straightforward, easy model. It's just visualization. It doesn't divide the data into two pieces. It takes the whole data, calculate alpha and beta, and we are done. But the second approach is machine learning approach. Basically, the model is dividing the data into two pieces. And then the first piece is used as training the data, calculating the coefficients, and using those coefficients, we end up with a test region, and in that test region we are using the first coefficients that we calculated using the trained data set, and then we are measuring the performance of our data. Basically, this model is more learning based model. Some portion of data is used for learning and the other portion of the data is used to calculate the performance of our model. I hope you enjoyed this video and I hope to see you in the next video.